Good morning, good afternoon, wherever you are in your day. This is Mr. Harris, and this is graphing quadratic functions. And I want to start with why we are doing this. Quadratic functions produce a graph called a parabola that looks like this and like this, and has applications. Obvious one is projectile motion, so like a ball, a rocket. Probably for you guys, like the bottle flip. Okay, so and then there's applications in electrical engineering and economics and other disciplines as well. So let's jump in, and I'll do some of these. I'll do some on the homework for you. The homework will be due tomorrow, and then yeah, we'll move on from there. I'll put a blog post on the web so you can put some questions up overnight. Hopefully I can get to some of those tomorrow. So anyway, let's dive in. So use a table or graph to get this, and generally whenever I have this, I'm going to go X, whatever my work is, and Y. And we've done some of this before. I'm just going to pick my two favorite easy numbers, 0 and 1, and plug them in. When I plug them in here, I get 0 minus 0 minus 2 is negative 2. And I get 1, gets me 1 minus 1 minus 2. Negative 2. Those are the same little odds. We'll work through this, and then we'll start unpacking some of the concepts as we go through the exercises. So I'm going to try negative 1, so I have some on the positive and the negative side. If I plug in negative 1 squared is positive 1. That's going to turn to plus 1. That's minus 2, so that will be 0. Just keep going. 2, 3, and then put in negative 2. Okay. Same process. 2 squared is 4. Negative 2 minus 2, 9. Negative 3 minus 2. And then we get 4 plus 2. 2 negatives and minus 2. And when we evaluate all this stuff, we get 0, 4, and 4. Let me say this: if at any time you need to stop this, that's why it is on YouTube, so you can stop and rewind and look through it. So help yourself, take some ownership, and do what you got to do. And graph it. X is 0, Y is negative 2. X is 1, Y is negative 2. Right there. Negative 1 and 0. 2 and 0. So there's a little extra point there that I'll have to get rid of. Let's zoom in here so you can probably see this a little bit better. 3 and 4. And negative 2 and 4. Okay, and what you get is you're going to get some kind of what's called a vertex here. And then you're going to get curve going up, and there'll be an asymptote or a line that it approaches that it never crosses. So it keeps going out gradually as it extends. Okay. But this picture is just fine. So that is what that should look like. Again, if you need to pause it at any time, go ahead and do that. Look for some whiteout, couldn't find any, just put a little no there. Should be doing this in pencil. Sometimes it's hard for the camera to pick up on that. Here's some notes. If it was me doing the homework, I would keep this out right next to my work so I can reference it, or even write these equations on the top of my homework until I got super comfortable with them. I'm going to put an abbreviation here, axis of symmetry. I'm going to go with AOS. We'll use that more than once and save us some space. Let's read through that. It just says if A is bigger than 0, it opens upwards, so you'll get this kind of shape. If A is less than 0, it'll open downwards, and then it tells you about max and min. As we work through these, this will become, some of this terminology will become more clear. So, 3, graph this. So, before I even get going, I like to do A, B, and C, so I know what they are. A is 1, B is -4, C is +3. Based on my notes over here that I had, if A is greater than 0, it opens up, so I'm going to go ahead and sketch that, and if I get a sketch that doesn't look like that, then I know I'm in trouble. And then the first thing I do is dive into the axis of symmetry. And the axis of symmetry equation, you remember, is x is -b over 2a, and that's all in our little cheat sheet corner up in 2. Okay, so let's just plug and chug. X is negative, b is -4, so -4 all over 2 times 1. Those two negatives will cancel, and I'll be left with 4 over 2, which is just 2. So what that tells me is x is going to be 2. Now, I'm going to learn from my mistakes here, and I'm going to go ahead and use a pencil to graph. Hopefully you can see it. If we aren't getting a good picture, then I'll dump it, but I'm going to at least start with that. So x is 2, so I get a line of symmetry, and that's just a dashed line at x is 2. Okay, so there's my axis of symmetry, line of symmetry. Okay, I can put that there. And what that, it's just like a mirror, so whatever you have over here, you're going to have over here, and that'll help save us some time down the road and reveal some interesting properties of this. So now it's just back on the grind. X, work, Y. Okay. So, plug and chug, and so I'm going to go with, because I know that axis symmetry is there, I'm going to go with 0, 1, and I'll eventually go to 2 and 3 just to check. But I'm going to start with this. Favorite numbers, 0, 0 minus 0 plus 3 is 3. 1 minus 4 plus 3 is 0. Okay, so now I'll graph those and see if I can't start to get a picture of this. 0 and 3 right here, and 1 and 0 right here. So I'm starting to get this shape here. I'm going to look for the axis of symmetry. By putting in 2, I know that the axis of symmetry is going to go through that point, x equals 2. So I plug that in, and I get 4 minus 4 times 2, which is 8, plus 3. And when I do that, I get -1. So now I'm right here with that point. So that's looking pretty good, like I'm going to have my curve, because remember, whatever I have on this side, I can just flip it over here. Now, I know that's the property, but I'm going to test it to make sure that this side is in a good spot. So I'm going to put 3 in, and 3 squared is 9, minus 12 plus 3, which gets me 0. So when I graph that, I see that those 2 points are the same distance apart and at the same vertical level, being the x-axis. So I feel good enough that I'm going to get a good picture. So I'm going to use that property here instead of having to do this, because this is kind of a pain. So let's make this easier on ourselves. So you got 2 spots here, so you go 2 spots here. Okay, and now I feel pretty good about our picture. Okay, as we go like that. Now it shouldn't be a point; it should be like a more gradual curve, but I'm not going to hit you too hard for that. So that's what that one should look like. All right, let's bump over to number 4. And again, pause it. If you need to stop, it's the beauty of YouTube. You pause it, look at it, view it, and do what you got to do. So again, is -2. B is 2, and C is -1. That -2 tells me that it's going to open down. So let's go ahead and go through this again. Again, you got your A, B, and C identified. You got a sketch of what it should look like. One is axis of symmetry, so let's get that. X is -b over 2a. Plug and chug. -2 over 2 times -2, which is going to get me -2 over -4, which is 1/2. Okay, so a little bit different here. Let's go ahead and get a line of symmetry. So x is 1/2 is a line of symmetry. Okay. So now let's just. To me, now 0 and 1 again look pretty good. I'll plug those in. I should get the same thing if my properties hold. Then I might kick out to 2 and -1, but just back on the grind. X work Y. So it goes 0 and 1. 0's in. 0 plus 0 minus 1. Plug 1 in, you get -2 plus 2 minus 1, which is -1, so I'm here and here. That's looking pretty good with my axis of symmetry. I'm going to plug 2 in, see where I get, and if I get -1 to match, I feel like I'm in a pretty good place. I forgot to talk about the vertex in the last problem, so I'm going to do that in 3 and 4 to give you a heads up on that or a little more information. So 2, if I plug 2 in, I've got 2 squared is 4 times -2 minus 8 plus 4 minus 1, and that to me looks like -5. And then if I plug in so 2, I've got -5 right here, so that's looking good because I'm going to have a vertex axis of symmetry right here. My other point should be here, so that's looking like my sketch. -1 squared is +1 times -2 is -2. 2 times -1 is -2, and then so I've got -5 again. So -1 and -5. Okay, now we still don't have the vertex point, and I'm going to back up to dive into that. So if I back up here, the vertex point is the max or min. So this is a vertex, and it's that apex point, max or min. In this case, that is a minimum value. That's as low as this function is going to go. You see the arrows going up here. So this is a min, and that minimum is that point, which is 2 comma negative 1. Okay. X is whatever our axis of symmetry is, and then we get a y off of that. So that's how you get the vertex. And again, pause it, look through it, stop it. I'll go into another one, and we'll do it a couple more times too. So over here, well, I know my axis of symmetry point is 1/2, so I need to find out the y that corresponds with x being 1/2. So if x is 1/2, okay, what do we get? And I'm gonna use some space here. So x is 1/2. What is y? And a way that we can write that is f of 1/2 equals whatever this is, minus 2x squared plus 2x minus 1. That's just a fancy way of saying, hey, we're going to plug 1/2 in for x and get some y. Alright, so let's go ahead and do that. And I'll start that over here. So I've got negative 2, and I put 1/2 in for x and square it. Plugging that in right there. And we've done this before. It's been a bit, but we've done it. Okay, and then I've got minus 1. And when I square the top and the bottom. So I get negative 2 times 1 squared is 1, 2 squared is 4, so 1/4. 2 times 1/2 is 1, and negative 1 is just negative 1. Now hopefully you see that these two are going to cancel right here. And then you've got negative 2 times 1/4, which is negative 2 over 4, which is negative 1/2. So that is my y. So x is 1/2, y is negative 1/2. Okay. So when I do that, I get, sorry, I had to bump those down. I graphed those at the wrong spot. I get that. Okay. So then let me draw this like that. My apologies for that. Doing this tonight after day number 2 with the baby, so my bad. Those points should not be there. Those should be here, 0 and negative 1, and 1 and negative 1. So you guys probably saw that when I graphed it, but my apologies. So that is what that should look like. Okay. So yeah, that's where we are with that. Okay. Feel free to back that up again. I just graphed those at the wrong point. Baby brain, my bad. So yeah. Alright, so let's bump down to the final example. A, B, C. It says your turn. If you want to pause the video here and take a run at it, go for it, and then you can either go through the steps or scroll through to the end. That's totally fair. A is positive, so going up. Axis of symmetry. Negative b over 2a equals minus 6 over 2 times 3, which is 6 over 6, which is 1. Okay, so my line of symmetry is going to be 1. out on this one a little bit. And then, yeah, I've got 1 here, so I'm going to start with 0. I'll just go 0, 1, 2. So if x is 0, negative 0 minus 0 plus 2 is 2. And if it's 1, 3 minus 6 plus 2 is negative 1. And if I put 2 in, I get, what is that, 4, 3 is 12, minus 12 plus 2, so I get 2 here. So that gives me a few points. Let's see what I've got when I do that. 0 and 2. 1 and negative 1. And 2 and 2. So that looks like my sketch. The vertex, it looks like I have that, but let me get 3. So if I plug 3 in, I get 3 squared is 9 times 3 is 27 minus 18 plus 2. So that is 11. And so I'll be 3 and 11. Now if I'm 3 and 11, that means I'm 2 spaces, so I'll go 2 spaces back here, so it means I'll be negative 111. Okay, so then, boomba, as my son says. There you go. Okay, vertex, which I walked through in the other one and forgot to wrap it up, but vertex is that point right there, that's a min. And that point is 1 comma negative 1. Okay, so you can pause it there and get that in. I'm going to jump back to 4 because I went through this whole vertex thing and forgot to label it. Probably because I caught that graphing error. So this is vertex. And that is 1/2 negative 1/2. And that one is a max. That's the highest point. All the rest goes down, so that's a max. And those rules are all in those notes up there. Okay. So that is that. Feel free to do what you got to do with that. I'm going to hit a couple on your homework to get you rolling, and then set you loose. You should have time to work on this today and tonight. So, what side are we doing? Skills practice. Number 6, we're just doing algebra. You don't have to graph at all. Kind of nice. So it's vertex equation, axis of symmetry, and the y-intercept. I'm just going to start with the axis of symmetry, which is x equals negative b over 2a. A is minus 3, b is minus 12, c is 3. So the negative b is negative 12 over 2 times negative 3, which gets me, those negatives cancel, and I get 12 over negative 6, and that gets me negative 2 is x. So there's my axis of symmetry equation. Okay? Or of course x is negative 2, whatever you gotta do. Okay, so once I have the axis of symmetry, I can get the vertex. So to get the vertex, I just take whatever the x is from the axis of symmetry and plug it in for x in the equation. And again, the other way to write that is f of whatever that is. So f of negative 2 is minus 3 times minus 2 squared minus 12 times minus 2 plus 3. Okay, so we get negative 2 squared is 4, minus 12, plus 24, plus 3. And when you add those together, you get 15. So the vertex will be a point. It's this x value, whatever the x from the line of symmetry is, negative 2, and then this y value. That's the f of f, or the y. So there's your vertex. Alright, let's see, we also got to get the y-intercept. Oh, this is a cheapie. So the y-intercept is always c. So c is 3. So the point is 0, 3, y-intercept, x is 0, you're on the y-axis. Okay, so that is that. Number 7 I have done as well. Max or min, minimum maximum value, domain and range of the function. So A is 2, B is 0, C is 0. There's nothing there for them. So picture I should have going up somewhere, so that'll help me with max or min. Axis of symmetry is negative b over 2a. Well, if I put 0 in for b, 0 divided by whatever is 0. So I know my axis of symmetry is going to be 0. So if I plug that back in the equation, 0 is x. If I plug 0 back in, I get y to be 0 too. So my vertex is 0, 0, and it is opening up, so that is the minimum value because you're going to get all these other values higher. Okay, so we got a minimum, we got vertex, or we stated the vertex, the maximum value, and domain and range. Okay, reminder: domain is all the x's. So domain is all the x coordinates. This hits all the x coordinates because, like we talked about earlier, this is going to keep going out. It might not get out there for a very long time, but eventually, infinitely, it will cover all the x's. So that is all real numbers. Now the range is restricted. Range is the y's. So range is, I mean, this function isn't anywhere down there. It doesn't exist down there. So it's only above the x-axis. So that is y greater than or equal to 0. Okay, so it can be y is 0, and it can be all, it just keeps going and going. But it does not, it's not negative. It's never negative for y. Alright, so that is 7. Wow, coming up on 29 minutes here. Whew, going strong. Alright, 11. So, this is what we did on the notes. So, A is 2, B is 4, C is negative 2. Axis of symmetry, negative b over 2a. Plug it in. Minus 4 over 2 times 2 is minus 4 over 4, which is minus 1. Okay, so there's x is negative 1. So I'm going to go 0, 1, and then I'll probably get negative 1 and negative 2 and see where we are. So if I plug in 0, and I'll get 0 plus 0 minus 2, I get negative 2. If I plug in 1, I get 2 plus 4 minus 2. I get 4. If I plug in -1, so looking to find my vertex here, -1, I get 2 minus 4 minus 2, which is -4. And then if I plug in -2, I'll get one more over here to see if I get something to check. Then I get -2 squared is 4 times 2 is 8, minus 8 minus 2, that is -2. So let's see how that all works out. If I've got 0 and -2, and I've got 1 and 4, I've got -1 and -4, and I've got -2 and -2. So again, using the axis of symmetry, these are one space apart. If that's two spaces apart, I get one over here. Okay, congratulations. That might be the longest one of these videos I've ever done. So, coming up on 32 minutes. Pause it. Homework is to finish both sides of this homework sheet, and yeah, we'll move forward from there and see where you are. Thank you guys for your time. Feel free to watch this as many times as possible. And if you don't like the way that it went down here, that's fair. I just pulled up a Google search, and there were about 2.3 million results in half a second for graphing quadratic functions, and that's all of them. And then videos, 245,000 in 0.32 third of a second. So there's plenty of other resources out there if you want to check that out too. So good luck, get after it, and we'll be in touch. Be well.